This is a brief video on integral domains and fields, section 5-2 and Gilbert's book on abstract algebra. First of all, we have the definition of integral domain. This is definition 5.14. Let D be a ring then D is an integral domain provided these conditions hold true. Number one, D is a commutative ring. In other words, D, the set D, has to obey all the properties for a ring. Additionally, the operation of multiplication has to be commutative. Number two, D has a unity E, and E is not equal to 0. And generally speaking, E represents the multiplicative identity. And this is the identity for the second operation, which generally speaking is the operation of multiplication. And last but not least, D has to have no zero divisors. In other words, if you multiply x times y and get 0, either x has to be 0 or y has to be 0. You cannot multiply two non-zero entities and get 0, whatever those entities are, in order to have an integral domain. So those are the rules for an integral domain. The next thing we have is the definition of what we mean by a field, F-I-E-L-D. And this is definition 5.17. Let F be a ring. Then F is a field provided these conditions hold. So once again, F is, generally speaking, a set of numbers. It could be a set of matrices, a set of classes. It could be a set of polynomials and various other entities. But it's a ring. F is a ring, so it satisfies all the ring's properties. Additionally, it has to satisfy these three properties. F is commutative, and that means commutative with respect to multiplication. Commutativity with respect to addition is a requirement for being a ring. So we already know that F has to be a ring. So we have to show that it's commutative with respect to the second operation. F has to have a unity, which we are calling E, and that unity cannot be 0. And last but not least, every non-zero element of F has a multiplicative inverse. Now, keep in mind here that this does not include 0. So 0 can be included in F, but we do not require to have a we do not require to have a multiplicative inverse. So that concludes this brief video on integral domains and fields. Have a great day.